Welcome to the latest Sustainable Futures seminar. I'm Dr. Helen Holmes. I'm going to be chairing today's session. I'm a lecturer in sociology and I'm also the Sustainable Futures champion for inclusive and prosperous futures. So we've got two talks today, each lasting approximately 25 minutes, and there's time for questions after as well. So I'm delighted to welcome Professor Allan Matthews and Dr. David Jones, who will each be giving a presentation today. Just a few housekeeping things before we get started. If you could post your questions in the chat, that would be great, and then we'll pick those up at the end of each of the presentations. I think everyone's cameras are turned off anyway, as is audio as well. So we'll make a start, and I'd like to hand over first of all to Professor Allan Matthews, who's a Professor of Surface Engineering and Tribology, who's going to be speaking to us today about towards sustainability and net zero with digitalised surface manufacturing. Over to you, Allan.
Okay, thanks, Helen. Let me see. So can you see that okay?
Yeah, that's fine.
Oops. Right, so I'm going to talk about towards sustainability and net zero with digitalized surface manufacturing, the role of the EPSRC DSM NetworkPlus. The first thing I ought to say is what do we mean by digitalized surface manufacturing? Well, basically this is all about digitalizing the coatings and the processes by which they are produced. And I'll explain why that's needed and something about the background towards this NetworkPlus which we have. It isn't just about net zero. In fact, it's little about net zero. It's more about the sustainability of manufacturing and the sustainability of products, which obviously will affect broader sustainability in society. It's also about something that we call the surface engineering sector, and I ought to explain what that is. Surface engineering is a relatively recent term which relates to the optimization of both the bulk material and the coating, and it's very important because more than 90% of all engineering product failures, such as by wear, corrosion or fatigue, occur at the surface. So it's very important that we optimize the surface and we do all we can to enhance those surface coating techniques. The background to this particular activity can be traced back to a thing called a special interest group, which was established by the Knowledge Transfer Network that reported in 2014. And they produced a report which they called Time for Strategic Change, UK Surface Engineering and Advanced Coating Industry. And that report's available online if you need it. What they found was that the coating sector in the UK is extremely important. Roughly £11 billion worth of coatings are produced every year. And those 11 billion pounds of coatings, some of which are illustrated here, things like paints, tin plate, cadmium coating, electroplating, all of those kinds of techniques, they're used in all of the main application sectors in UK industry. So we're talking automotive, construction, aerospace, healthcare, etc. And for example, automotive uses about £2 billion worth of coatings every year, construction about 3 billion. So it's an important sector. And it's wound up now in the Industry 4 story. As you know, we've gone from Industry 1, which is the industrial revolution, through to mass production, the Henry Ford type of production, Industry 2, and then PC and automation when this Industry 3, and now we're in the smart factory concept, which is Industry 4. So that smart factory involves the installation of so-called cyber physical systems to monitor and control manufacturing processes. So we fully digitalize it, and we can produce things on demand and often to what they call near net shape. And it was realized that the coating sector is quite backward when it comes to installation of digitalization and monitoring systems. So it was said that we need to install it in order to enhance the country's productivity and the quality of the products that are produced. And that was why this particular NetworkPlus was created, to try and encourage this. At the same time, the government's industrial strategy came out in December 2018, and they identified 4 main grand challenges or pillars, which they said drive productivity. And you can see here we've got AI and data, mobility, aging, and clean growth. And all of these are affected by coatings, and particularly the digitalization of coating processes obviously fits in with the government's view of the industrial strategy. At the time of that report, they said that digital technologies would enhance the economy by 455 billion over the following 10 years. And so you've got that driver, and you've also got the fact that the industry is worth about 11 billion, but that 11 billion pounds worth of coatings affects 140 billion pounds worth of products, which go on to affect over 350 billion pounds worth of company turnover. So it's a very important sector. And you could argue that 11 billion pounds worth of coatings create products which wouldn't exist if it wasn't for those coatings. And as I say, we've got a NetworkPlus to try to get, mostly to get academics together. And it was said that no UK university has the required interdisciplinary expertise, and there's a lack of connected knowledge in the area of digitalization. So we were given support by the EPSRC to set up this thing called the NetworkPlus, to try to bring academics together to research this field and to work with industry. That Made Smarter review also said that the sector which is most in need is the SME sector, so the small and medium enterprise sector in industry. And it's true that most of the coating companies are small and medium enterprises. So the idea is to close what they call the digital gap. And that aims to achieve better utilization of assets, reduce dependency on tacit knowledge, reduce the time and cost linked to product verification, improve and give visibility to business performance metrics like yield, right first time, cost, delivery, quality, and equipment effectiveness, and enable and improve design for manufacture in order to ensure that when products are designed, they're designed with the idea of the coating being present, which didn't always happen. People used to design products and they failed for various reasons, so they slapped a coating on them to try to solve them. This was often called the band-aid approach to coating, where you maybe got wear or corrosion and they would just stick a coating on to solve it. Far better to incorporate the coating at the design stage. And this opens up new business opportunities and provides a framework for developing a more resilient business. Also, the digitalization impacts on the productivity of the businesses. So if you do a search on 7 waste, or 8 waste, do a Google search, you'll get diagrams like this, where they recognize that things like overproduction, defects, and overprocessing leads to reductions in the value added, or the reductions in the productivity, so that by introducing digitalization, we improve productivity and we reduce waste in the manufacturing process itself. So that's, if we digitalize, we avoid overproduction, too much inventory, too much transportation, too much motion, too much waiting, defects, and overprocessing. That's the other reason to digitalize coating processes. So coatings can have a very significant beneficial effect on sustainability. They allow scarce material sources to be conserved. So you apply the scarce material at the surface where it's needed rather than making the bulk from it. Let's get a laser pointer. So you also reduce energy usage by reducing, for example, friction in materials and in engines, etc. In aircraft, you can make them more efficient by installing what they call thermal barrier coatings to make gas turbines more efficient. You can achieve lightweighting with other changes and the developments in coatings, which I'll illustrate shortly. We improve the power generation efficiencies, for example, in ground-based turbines and wind turbines, and we reduce toxic effluents. So you're probably aware that the old style coating techniques like electroplating used to discharge toxic effluents into the rivers, and we can now avoid that with better coating processes. Those coatings and treatments are particularly vital in all aspects of energy sustainability, both in energy generation and conversion, in energy conservation, and in energy storage. So, for example, in energy generation, we coat gas and steam turbines to make them last longer and be more efficient. We use organic coatings for corrosion protection in solar hot water systems. We use anodizing to provide corrosion protection to titanium and aluminium alloys used in offshore structures for wave and wind power. And we use coatings, obviously, in photovoltaic devices and in fuel cells. In terms of energy conservation, we use liquid lubricants to reduce frictional losses in engines and other machinery. We use solar controlling coatings for architectural glass. And we use polymer coatings to control building temperatures. So these are just some examples of how coatings influence sustainability. In storage, we've got lithium-ion batteries, which are basically multi-layer coatings. And increasingly now in hydrogen fuel cells, we have coatings which are based on yttrium-stabilized zirconia to produce the hydrogen fuel cell. So it's a very important sector for sustainability. I've talked a little bit about reducing friction, and just to show you how this can help, if you can coat a gear, you can increase what we call the fatigue limit. We can increase the load that we can apply without fatigue occurring on a gear. And that means you can make the gear smaller and lighter, and you can improve the efficiency of the engine in that way. So you can reduce the failure of gears in all kinds of things, in all kinds of ways, reduce pitting and fracture and seizure. And you might say, well, that sounds it's more to do with the internal combustion engine, but in fact, it's very important for things like wind turbines. You might remember I don't know why I'm muted. Am I muted, Helen, or can you hear me okay?
I can hear you now, Alan. It's fine now. Just went off for a moment.
Yeah, okay. We can coat wind turbine gearboxes, and we can make them last 25 years or longer. So it's just an example of how we can apply coatings and make machinery last longer, and therefore give a sustainability benefit for longer. For some reason now it's not going forward. I don't know why. There we go. This is an example of where we took weight out of a landing gear of an aircraft. This was made of steel and bronze, and we managed to replace it with titanium bearing. We took hundreds of kilograms out of the weight of the plane, and therefore made it more fuel efficient. In fact, remarkably, just changing that one bearing in the undercarriage produced a saving of £7.6 million in fuel over the life of each aircraft, and that represented about 36,000 tons of CO2. So it gives you a better feel for the benefits that we can obtain for sustainability by using coatings. So what this network's trying to do is to kind of spread the gospel of these kind of benefits. And we, first of all, we had to identify and benchmark UK capabilities. We had to enhance the capabilities by introducing digitalisation and promoting a culture change in the sector. Provide a fora for discussion on how we introduce digitalisation and improve the coatings that way, and try to establish a well-informed and aware interdisciplinary research community that's agile and committed to moving the sector forward to the new age of Industry 4.0. So that's the smart factory, which I mentioned, and support fundamental research and feasibility studies and demonstrator projects to move in that direction, and ultimately to be the go-to place for uptake of digital technologies. We started off with about 27 members with 16 organizations, and now we've got about 1,000 members, academic and industrial, and 74 organizations. These are just our original partners. There are 5 initial universities involved in it. There were Manchester, Queen's Belfast, Sheffield, Cranfield and London South Bank, and these are just some of the companies that were on board with us when we started this, setting this network up. We have a management team, we have independent advisory board, and we tend to divide up the activities to networking, horizon scanning, challenge identification, fundamental research and feasibility studies, and development of demonstrators, and then training and development. What sets apart a NetworkPlus from a normal network is that the NetworkPlus is given money by the EPSRC to fund research. That's why it's called a NetworkPlus. So we run network-wide events, focus workshops, expert working groups. As I said, we fund feasibility studies, and these can be things like looking at self-repairing processes, looking at faults, why they occur, projects just to digitalize processes, that kind of thing. And we run demonstrator projects at the core partners, looking at things like predictive digital twins, where we produce a digital version of a process, which we can then monitor the real process against the digital twin of it and see if it's going out of control, that kind of thing. So various digital activities to make the processes more effective. And training and development is a very important part of what we do. We're very much focused on early career researchers. So we do mentorship for ECRs, we do forums for them, secondments into industry, summer schools for ECRs primarily. And then we support an apprenticeship scheme, which is run by something called SELF, which is the Surface Engineering Leadership Forum, which is an industry body which is working with us to try to help the training aspect of what we do. We have a strong social media presence. We have a website, which is here. We're active in Twitter, in LinkedIn, etc. So I would recommend that you go to the website, which will tell you more about what the NetworkPlus is doing. We're spreading right over the UK. We're even spreading overseas because we realise that all the major developments aren't all going to occur in the UK. So we've got active liaisons with academics in Australia, in Far East, in India, and in Canada is very, very strong. We're growing, probably you can see here, our LinkedIn has grown to well over 1,000 now, just as an example, and email distribution is going up, so it's effective as well. And we run webinars, and these are just some screenshots from some of the many webinars that we've run. I think we're well over 20 now. I think we're well over 30 that we've run, and they are available free for anybody who registers on our website. We run courses. For example, we ran a COP 26 challenge website, and you know that we run we always have good female representation, ECR representation, and BAME representation. We ran this particular one in October 2021, and we probably I shouldn't say it, but many people said it was one of the best COP webinars that they actually attended. This is just the program. Again, you can see this online. The feasibility awards, which we fund, are listed also online. I won't go through every one, but we do things like machine learning to make processes more effective, and different coating processes. We're improving them and developing them to make them cleaner, more sustainable, and make products last longer. The second feasibility award was aimed at what we call biosurfaces, so it was aimed towards COVID and biofilm removal, antibacterial coatings, anti-fouling coatings, antiviral coatings, that kind of thing. So we can tailor the feasibility awards to meet current needs. The COP event was preceded by an ECR COP engagement, and again we had 13 ECR speakers from 6 universities. The statistics are there, and again it was an excellent presentation. In fact, it was so good that we put 3 of the ECR speakers in the main COP event that we ran. We're collaborating with many organizations, governmental organizations and companies. We're also collaborating with other networks. NetworkPluses are very favored by EPSRC now. There are a couple of others in the university, and there's one called Sprite, which is dealing with security and privacy and that kind of thing, and this one's at Aston. It's dealing with manufacturing symbiosis. So we collaborate with those as well. I think there will be more and more NetworkPluses because EPSRC love them, because the academics do all the work for them. In terms of, that's one reason anyway, in terms of selecting who should get the money. And we are having a stronger footprint in terms of getting more and more EPSRC grants. We've just got a £3 million grant to look at self-sensing coatings and others. I realise I should be finishing, so I'll finish there. Thank you very much.
Thanks, Alan, for a fantastic presentation. It's great to hear more about the network as well. So I'm going to open the floor now to questions, and there's a couple already in the chat, so I'll just read them out. So the first one's from Maggie Fossier. Could you talk a little bit more about the photovoltaic coatings? I think I've heard of a paint with PV capabilities. Is this something we could start thinking about coating all sorts of outside facility with?
Yeah, absolutely. In fact, Swansea University have a project to coat buildings which will self-generate. So it's very, very exciting. And we are researchers at Manchester collaborate with them. You know, photovoltaic coatings are coatings, so they fit well into what we're trying to do.
Great, thank you. And then there's another question from Caroline Stanton. There's actually 2. Could you tell us a little bit more about how businesses have collaborated so far, particularly SMEs? And then as a follow-up, have you faced any challenges in relation to getting businesses engaged and collaborating?
Well, Thanks, Caroline. And Caroline, by the way, has been tremendously helpful to us in setting up KTPs with companies. KTPs are a fantastic mechanism for getting academic research into industry. And we've worked with one excellent company near Widnes, and they are working on print rolls. So they're coating large rolls which are used in printing. So that's a matter of thermally spraying a coating and then texturing it with a laser. And we're just talking with we've just got another KTP, knowledge transfer partnership, with another company that's looking at machinery that's used in the hydrogen fuel sector. So I can strongly recommend KTPs, and I could also strongly recommend that you should talk to Caroline. So thanks for that, Caroline, to give me a chance to mention KTPs.
Thanks, Alan. And then there's a question from Francie. Do you know any sustainable material that can be used as an alternative to concrete in construction? Well, this is a very good point, and people are looking at putting graphene into concrete and all kinds of things. You probably realise that concrete is one of the least sustainable in terms of its impact on the environment. I don't personally know the answer, but I know that many people are investigating concrete and making it more environmentally friendly. Thanks for that. I have a question of my own, Chair's prerogative. Do you plan to continue the network at the end of the current EPSRC funding? And if you do, how do you plan to do that?
Well, we very much want to. As you can see, it's very successful. But the EPSRC has kind of originally set out its stall that it wouldn't renew networks. It probably thought that network will achieve what they have to achieve, and then, you move on. Now, as it turns out, one of the Manchester networks has just been renewed. That's the Sprite one. And I feel that the important thing with the network is for it to remain valid and useful, and to be agile and able to develop. And obviously that particular network has managed it. So we're just looking at what we can do to maintain the topicality of what we're doing, and hopefully get it extended. But for example, I think that there will be security issues, so we maybe possibly get together with those people in that network. And ultimately, of course, it will be nice to be self-sustaining. And maybe our webinars, which are very popular, could see a route to us becoming self-sustaining and running conferences and that kind of thing.
Oh, yeah, that would be great if you could do that, wouldn't it?
It would.
And another one from me, because I'm conscious that nobody else added a question in the chat just yet. So with the feasibility awards, you've got some great projects there. How do you select projects for funding, just in case anybody's interested? Yeah,
completely independently and completely anonymously. So we don't select them. We have got a group of one guy's an industrialist, in fact, another lady's an industrialist as well, and somebody from the KTN, sorry, from the the KTN, the materials expert in the KTN as well, the knowledge transfer network. And I say it is anonymous, and it's done independently of us, which is as it should be.
Yep. Great, thank you for that. Well, we don't appear to have any more questions, so I think we'll hand over to, oh, hang on, Maggie's added another one. Does the fact that the process is digitalised make it more transferable? Yeah,
I'm not sure what you mean by transferable, but what we do find is that some sectors are more digitalised than others. In fact, the digitalised community speak their own language. And, you can learn from what one sector does, and then that can be then transferred into, say, into the coating sector. We deal with engineering coatings, so these are coatings for wear and corrosion, etc. There's another coating sector, which is the one that deals with thin film devices. That's highly digitalized. So the sector that deals with semiconductors and optical coatings, etc., is very digitalized. So we are learning from what they do in terms of what we call the cyber physical devices, which monitor the process. So it sounds like a fancy term, but these are basically just sensors that are built into the process, and we can utilize what they learn in terms of process control into the engineering coating sector.
Great, thank you, Maggie. I hope that answered the question. Yep, she said thank you, so that's great. So thanks very much, Allan. That's been a fascinating presentation. I'm sure anyone with any further questions can contact you if they want to, and we'll hand over to David. So I'm very pleased to welcome our next speaker, Dr. David Jones, who's going to be speaking today about greener operations, sustainable perioperative care. Over to you, David.
Well, thank you very much, Helen, and thank you very much for the invitation. So you've probably not heard of me in the university because I've been a clinician, but most of my career I've been a general and colorectal surgeon. I'm currently working as something called a medical examiner in Wythenshawe Hospital, and I developed an interest in sustainability towards the end of my operating career, and greener operations is a project I'd like to share with you, and it's something that you can all get involved with and help us out, and I'll tell you how towards the end of the talk. And I'm going to tell you about the Greener Operations Priority Setting Partnership, which is a bit of a mouthful. This is a national project which we're hosting in Manchester University NHS Foundation Trust through charitable funds that I have in MFT Charity. It's allied to the National Institute for Health Research. It's got huge national partners such as Medical Royal Colleges, the Centre for Sustainable Healthcare, Allied Health Professionals, and many more. And I'll talk you through the process later on, but the aim is to set a top 10 priority for research funding, and in this case, is to deliver more sustainable surgical operations. So as I said, this is me towards the end of my operating career, and just sort of observing my practice. There are a lot of things that creeps into my practice that were clearly not sustainable. The bottom two pictures just show some of the waste from a simple operation. And I'm sure this is also very relevant to the last talk in terms of all the coatings on these materials that we're just throwing away. I've just completed a year as president of Manchester Medical Society, which is as old as the university. And the theme for my presidential year was sustainable healthcare and sustainable surgery. So we're all targeted with reducing our carbon footprint, and whether net in terms of net zero is the right word, but the NHS is responsible for something like 4% of our CO2 equivalent emissions. And to get to net zero, this is going to mean a huge change in practice, and that practice or changes in practice needs to be evidence-based and driven through research. And this research is likely to be multidisciplinary. As in the last talk, that's not something that I have any specific knowledge about, but I can tell from listening to Allan that clearly a lot of the materials that I'm using may also be relevant for him. So I think there's huge areas and huge potential for research in this area. So MFT, you can look this up, have just released their Code Green plan for getting to net zero in MFT in Manchester. And the largest part of our carbon footprint is actually our supply chain and procurement. And really, I know very little about how the equipment that I've used for many years is procured, whether this is procured in a sustainable and responsible manner, and how any of the materials that I've used were coated. the emissions associated with healthcare, around 6%, and 20% of our footprint is our direct contribution from use of energy, anaesthetic gases, travel, waste management, and water on site. So you can immediately see there are lots of different areas that we need to address if we're actually going to get to net zero, and we probably need help from outside the NHS, from people such as yourselves. Now, as a clinician, my priorities have always been on patient outcomes, and this is something called the National Bowel Cancer Audit, the latest edition of which was published just last month, and this is in the public arena along with my outcome data. And we're very driven by, as we should be, by the patient in front of us and getting the best outcome for that patient. And this desire to achieve the best outcome trumps all other considerations. It's easier for me now to talk about this and how we need to change practice because I'm no longer treating patients with colorectal cancer, but my figures of mortality are still in the public arena, and anybody can look up the mortality rate for any individual consultant. And this has pushed sustainability to the back of our thought when it needs to come to the forefront of our thoughts when dealing with patients. And you may have seen in the press, with COVID, there's something like over 6 million people waiting for NHS treatment that they couldn't get during the pandemic. So this is a huge amount of healthcare with a huge carbon footprint that we've got to tackle. Now, if we take a typical operation, let's just sort of drill down to what we actually do and think of one of the commonest operations, like a inguinal hernia. That's a hernia in the groin, a swelling in the groin. And this is a typical operation. The carbon footprint is estimated to be about the same as driving from London to Edinburgh. There are two main bits we can perhaps think about. If you're going to have an operation, you're going to have some form of anaesthesia, and this is my colleague Cliff Shelton on the left, who's a joint lead of the Greener Operations project, and they've got their hotspots, which we'll talk about, such as electricity and anaesthetic gases. And then there's the surgical footprint itself, a lot of which relates to just the patient pathway, how we get people in and out of hospital and back home, the consumables we use, the PPE we used. And there's lots of different areas that we need to start thinking about. People have started to do some detailed research into the carbon footprint of an operation, and this is the only really technical slide, and you don't need to look at it in great detail, but it's a systematic review that was published 2 years ago by Roseanne and colleagues from Brighton, just looking at the evidence for the carbon footprint of an operation. And you can immediately see there are multiple variables. If you look at the graph on the right, this has the carbon footprint of different ways of doing a common operation, that is a hysterectomy, and there's over a twofold difference in the carbon footprint of an operation, depending on how you do it, whether you do it through the vagina, whether you do it through a conventional abdominal decision, whether you do it with keyhole surgery, or, as is the mode now, to start doing things with robots, which has the highest carbon footprint. But there's lots of scope for research around this because it may not be that simple. So if you go back to our inguinal hernia, although it's an operation that people were operating on hernias at the start of the 19th century, before the advent of anaesthesia in people who had strangulated hernias. And we immediately have lots of different options. You can have an open operation, that's a cut in the skin over the hernia, and that could be done using local anaesthetic, like you might get at a dentist, infiltrating the area with some local anaesthetic drug. It could be done by numbing the whole part of the lower body with a needle in the back, a spinal anaesthetic, or perhaps more commonly under a general anaesthetic. There's a fashion now for doing this by keyhole surgery. This is what we call minimally invasive surgery. is associated perhaps with a quicker recovery, but always is done under general anesthesia. So we've immediately got lots of different options. Now, if we just think about a general anesthetic, I would imagine there's many in the audience that may have had an anesthetic. And if you're going to have an anesthetic, you've got to pick a poison that's going to keep you asleep. And the traditional way of doing that is with inhaled anesthetic gases. More recently, we've developed intravenous anesthesia. And inhaled anesthetic gases are responsible for something like 2.5% of all of our NHS emissions. And these are halogenated hydrocarbons. The commonest one is sevoflurane. We also use a lot of nitrous oxide, which is used as a carrier for other inhaled anesthetic gases. And all of these are potent greenhouse gases. The alternative that's being developed is intravenous anesthesia, which involves more electricity, packaging, plastic syringes, waste, pollutants, and it's perhaps a more challenging technique for an anaesthetist to use. Now, if you ever go into the Stopford building in the university, there's a number of displays relating to developments in Manchester in the university. And this is a display around Michael Johnston, who's credited with the first clinical trial of an inhaled synthetic anaesthetic agent, which was halothane at Manchester Royal Infirmary back in the 1950s. This has proven to be very effective, and over the years, halothane has evolved into more effective, safer, easier to use inhalational agents. And now anesthesia using inhaled synthetic agents is very safe, but they're all potent greenhouse gases. And these are some estimations from the Royal College of Anaesthetists that an hour of surgery using sevoflurane is equivalent to driving 5 to 10 kilometers in a car. If you go down to desflurane, which has been developed to be safer, more effective, quicker to use, quicker recovery, this has a carbon footprint equivalent to driving 200 to 400 kilometers. And a ton of desflurane is equivalent to 3,714 tons of carbon dioxide. It was developed with good intent, but we now realize it's a potent greenhouse gas. And this brings me to John Tyndall of Tyndall Centre fame, who is credited with describing the physics behind the greenhouse phenomenon. He also studied glaciers, one of which was the Allan Glacier in Switzerland near the Jungfraujoch. And this is a picture of the top of the Allan Glacier near the Jungfraujoch. And there's a memorial to John Tyndall near the foot of the glacier. And people have actually measured the atmospheric level of inhaled agents at both Jungfraujoch and in Antarctica. And the graph, the one from the bottom, shows the gradual increase in the detectability of desflurane, the most potent anaesthetic greenhouse gas, over recent years. Now, there is an alternative, and the alternative is total intravenous or TIVA anaesthesia. But the drugs used, they're very effective, but they do become pollutants. They persist in the environment. They're particularly toxic to aquatic creatures, and their use involves a lot of electricity, syringes, packaging, disposal, and they're not as easy to use. It needs perhaps more skill and more attention to detail. But people are turning towards total intravenous anesthesia as the alternative to these potent inhaled anesthetic gases. And this starts to become a very complex picture, because when we start to put this in with the different ways of operating, it starts to become difficult to know which is the best procedure to perform and what is the best advice to give to patients. And it's when you think about how we operate, this is again the picture of just some of the waste, some of the PPE, some of the gloves, which we just have got used to throwing away at the end of every operation. The procurement around these and the ethics of procurement is a different topic, but very important. And we use these on the altar of infection control and preventing CJD, but it's probably safe to go back to using reusable instruments, but we need to demonstrate that by research. And this is just one small example. I noticed that we use a thing called diathermy, which is essentially a bit of kit to deliver electrical energy to a vessel to heat it up and control the bleeding. And I found that on every tray there's a reusable diathermy, which is perfectly acceptable, but they're also opening an easier to use finger switch diathermy, which comes with 3 meters of cable. I questioned this, but I was told it was very cheap. It only cost £1.64. But this is a completely unnecessary use of resource and procurement of something which we don't need. And I'm sure it's got some interesting coatings. When it comes to an operation, I mentioned the patient-reported outcome and the outcomes for patients, and these are the outcomes for patients undergoing inguinal hernia surgery. We stopped publishing these back in 2017, but these are 2 different forms of quality of life assessment after patients undergoing hernia surgery. And you can see that only a small a minority, perhaps 39 or 50%, were actually improved by the surgery. And this is because we've been operating on people with the presence of the condition, perhaps have no symptoms from the condition, but when they have the operation, then do start to get some symptoms such as pain in the groin. And we've been doing a lot of surgery on people we've possibly made worse, and this was associated with a significant carbon footprint. So we need to think about how we select patients for operation. We need to think about the environmental impact of the different options and how we incorporate this into discussions with patients, how we get to include discussion of environmental issues when discussing the need for surgery. And another local development was hip replacements. And again, in the Stopford building, there's a display to hip replacements, which was developed by Professor Sir John Charnley, who was Professor of Orthopaedic Surgery 50 years ago. And hip replacement is one of the big successes of surgery. And this is the graph of temperature change going back to pre-industrial levels today. You can see that hip replacement surgery started in 1960, and since then it's become a huge volume of activity with a huge carbon footprint in the NHS. The latest data on outcomes show that we're performing just under 100,000 hip replacements a year, and this is an operation that is associated with high levels of patient satisfaction. 97.2% of patients report an improvement in health. So it's a very effective operation. But we know there's lots of variation in technique. And one of the key things is, how do you put the hip replacement in the bone, the femur? Do you cement it in place with something called methyl methacrylate? This makes it more secure. It's easier to do, but it's much more difficult to revise if that hip replacement needs to be replaced in the near future. The alternative is an uncemented prosthesis, which is much easier to revise should the hip replacement need to be revised in later years, but it demands more technical expertise. And we've been trying to reduce the variation in healthcare by something called Get It Right First Time. And this is, we've observed variation in practice around the country. The first Get It Right First Time program related to orthopedic surgery and hip replacements. And this just shows some local data. If you go in Stockport, the blue part of the graph shows the percentage of patients having a cemented hip replacement, which is very low, compared to Bolton, where the percentage of patients having cemented prosthesis is very high. And there's this huge variation in clinical practice, which can't really be justified. Because the Get It Right First Time programme was the first one in that initiative, they've had time to go back, they've had time to look at reducing variation in clinical practice. And by selecting the right patient for the right operation, using the right technique, it's estimated that over the last 5 years, almost 50,000 potentially unnecessary procedures have been avoided. And they've actually looked at the carbon footprint of those potentially unnecessary operations, which is quite significant. So we're making progress, but there's lots to do. I'll just put an advert in at this stage for the Manchester Surgical Skills and Simulation Centre, which is where we're training surgeons on fresh frozen cadavers next to the anatomy department. This has been leased by MFT, and it's a fantastic, safe environment for training and evaluation. There's a whole pile of kit that we're using on the right that would previously have been thrown away. And I think actually there might be some potential for collaboration and research in this centre if we're looking at new technologies around healthcare and surgery. So we need to make operations greener. That needs to be evidence-based, and that needs multidisciplinary research. And this is where we get a bit technical. So the Greener Operations Sustainable Perioperative Care Priority Setting Partnership is something we're doing with the James Lind Alliance, which is allied and supported by the National Institute for Health Research, which is a major funder for health research in the UK. I'm joint lead for this project, and we've got lots of national partners. It's supported by the Royal Colleges of Surgeons of England in Edinburgh, Association of Anaesthetists, Royal College of Anaesthetists, many allied healthcare professionals. So it's a project of huge national importance we're hosting in Manchester. Now, you may not have heard of James Lind, but he was a Scottish naval physician in the 18th century. And he looked into scurvy, which is due to vitamin C deficiency. And sailors had a very high mortality rate, such as on George Anson's voyage around the world in the 18th century, where 3/4 of the crew died from scurvy. And James Lind did one of the first clinical trials with a control group comparing different ways of potentially reducing scurvy, some of which sound quite revolting, like giving people seawater to drink. But that trial, which he published in 1753, showed that citrus fruits could prevent scurvy. So now the James Lind Alliance runs priority setting partnerships. And the outcomes of these priority setting partnerships is taken into account by bodies which award research funding, such as the National Institute for Health Research. So the James Lind Alliance raises awareness of research questions, and it has a collaborative approach. The important bit is that it involves patients, carers, clinicians, and professionals working together. So it's not just the voice of the professionals who may have a vested interest in a specific condition or a specific treatment, but taken the public view into account as well. And this is a well-followed pathway and process. And at the end of the process, it agrees which uncertainties about treatments matter most and deserve priority for research. So the process involves an initial surgery, and I presented this to you last year, and this was a very open surgery, open to the public and professional, just asking very general questions. There's then an interim survey, which is generated from the response to that survey, which leads on to the final priority setting, which we're hoping to do later this year. So the timescale for this Greener Operations Priority Setting Partnership, we started last year, and from the first survey, we got over 1,500 suggestions which were in scope of the project. And it's taken us longer than we thought, as does all research, I guess, to distill this down into key questions. And we've got that down to 60 questions to go into the interim survey. We have to do a detailed literature review to check the questions are not already answered. I'm probably talking to you a week too soon because we just got to the final stage of that literature review, which we've signed off yesterday. So the interim survey, and I would encourage you all to participate, and we'll share the link with you afterwards, is hopefully going to be launched next week or the week after. You'll just be invited to pick 10 priorities out of all of those that are available. Those are then taken to a final priority setting meeting on the 15th of June, and we're hoping to announce the research priorities the following day, which is Clean Air Day. And those top 10 priorities for research we will then take to commissioners for research, and usually those that are supported by a James Lind Alliance initiative are more likely, it increases the likelihood of a bid for funding being successful. I can't actually share the questions with you yet because we have to get it signed off by the steering group, but there's a wide variation in topics, many of which will be highly relevant to people outside the healthcare community. So please do take a look. Varies from patient selection for surgery, the patient journey, the equipment we use, the anaesthetic agents, the surgical techniques, the carbon footprint. But there's something for everyone there, and your opportunity to prioritise. And the NIHR actually announced huge funding streams for healthcare associated research at COP26. Their bids are open concurrently at the same time. But I'm sure if anybody was involved in putting a bid in, something that comes up in a James Lind Alliance priority setting partnership is more likely to be considered more favourably. So what I'd ask you to do is please help us out. If you Google Greener Operations, it did this morning come up as the first thing in Google, please do complete the interim survey. You'll actually be able to express an interest in attending the final priority setting meeting, which will be in London on June the 15th. And people involved, such as myself, can't actually influence those final priorities. That will be an appropriate mix of public, patients, carers, and professionals who've expressed an interest in attending. So if that's something that you might be interested in, you can potentially get involved. And I would ask you to think, is your area of research in the university relevant to healthcare? Do you have any ideas for collaboration? So I'll end there just with the advert for the Greener Operations Priority Setting Partnership. Do Google us. I'll get Lauren to share the link with you, hopefully next week or the week after. And please do help us out with this project. Happy to answer any questions, and back to Helen.
Thanks very much, David. That was absolutely fascinating. I had no idea about the admissions from anaesthetics, so that's a big surprise to me. We don't seem to have any questions in the chat at the minute, so I'll just give people a chance to type. I actually have one. So you talked about hip replacement. I thought that was really interesting about it having such a high satisfaction score. And I wondered, thinking about that and people obviously wanting hip replacement surgery, do you think it's possible to discuss issues of sustainability with patients who are facing major surgery such as that, and how would you do it?
Well, I think that's perhaps something you could fill the survey in and tick, because involving patients in decision making, I think, is one of the biggest challenges. You know, we are accountable financially, so there's no reason why we couldn't have a carbon footprint as well as a financial footprint for healthcare. Patients are actually very interested, certainly in terms of waste. The waste itself isn't the biggest problem in our carbon footprint, though it's obviously important as a pollutant. But yes, I think research to show, you know, how we involve patients is likely to be very important. I'm in a slightly difficult position, Helen, because I have to be neutral at this stage in this project. But I wouldn't be at all surprised if that's an area you could tick the box for to become a priority. And I did some research with the Macmillan Department of Nursing 20 years ago on decision-making in colorectal cancer surgery, and patients actually want to be involved, they want to be informed, though the research at that stage showed they were probably happy to let the clinician make the decision, but that may have moved on.
Yeah, I think maybe it would. Yeah, people want to have a bit more of an input, don't they? I would imagine. Thank you. That we've got a few questions in the chat and lots of you know, thank yous and fascinating. So Max asks, I wonder whether you could comment on the relative impact of clinical practice, e.g. material use and approach to treatment, and operational decision making, e.g. better elective surgery scheduling, supply chain management, etc., to reduce waste, respectively, on reducing CO2 footprints in healthcare. Is either one more important than the other?
I think we have to tackle every area, and I think it's bringing sustainability to the forefront of clinical care, because we do have a financial budget. I couldn't just spend as much money as I wanted doing a hip replacement, so there probably isn't a reason why I couldn't have a carbon budget. And probably we do a thing now you wouldn't probably know about. We do a thing called the World Health Organization checklist. So before the start of every operation, we have to discuss with the team what we're going to do. And I think those discussions around sustainability, the products that we're using, it's been very easy to hide behind single-use items, and we've got rid of the ability to sterilize stuff on site. But there's evidence, though it's still area for research, you know, that we should go back to reusable equipment. There are lots of issues. It depends where you procure from, what their electricity source is. So kit from Australia or papers from Australia, where they're dependent on coal power, might have a different carbon footprint to here, or say in Scandinavia, where they use more sustainable energy. So again, Max, I'm sure there's a question or two you could tick in the Greener Operations Survey when we release it, relating to those themes.
Thanks, David. So we have another question from Stephanie. Are there lessons to be learned from lower income settings?
Absolutely. And there is a question about that you could potentially choose. I'm giving things away now. So cataract operations in India have the lowest carbon footprint of any operation. They're done under local anaesthetic compared to UK and USA, where for the same clinical benefit, the carbon footprint is double. And we have to change our practice. I mean, the easiest way for me to do a groin hernia was under general anaesthetic. I can do them. I was taught to do them under local anaesthetic, which is probably the greenest way to do it, because then you don't use any gases or any of the intravenous drugs. But it was easy, and I'm guilty of it, for someone to put the patient to sleep and then for me to do the operation. So these are all challenges to our practice, and these need to be research-based.
Thanks. Yeah, thinking again about what the patient wants as well comes in there, I suppose, doesn't it too? Maggie's asked, are there some obvious PPE waste in the rest of the practices, e.g. consultant examination, or more equipment that could be reused? She added, I did not know that the main driver had been CGD. Well,
it became normalised deviance because I obviously getting on a bit, and I never used a disposable surgical gown or a surgical drape or a disposable bit of equipment for probably the first 15 years of my consultant practice. But then CJD came in, and it's very convenient just to open a packet and it's sold to us. It's a very nice piece of kit. But there is evidence now, you know, you can go back to reusables. We just need to work out where we do that. There's energy involved in, you know, sterilisation and such like. But it's become normalised deviance, and it's obviously very heavily sold by industry. But I think industry we have to partner with industry and they have to come on board. But a lot of the kit that we use, I mean, there's no real indication for using a disposable gown. The risk of CJD from, equipment that's sterilised must be minimal. And there is a risk to everything we do. The risk from CJD is minimal, I would say. You would find an alternative view perhaps, but I think by and large, we think going back to reusables is the way forward, and certainly outside of the, in other areas of the globe.
Great, thank you. Matt asks, would introducing different coatings, as Alan discussed before, enable certain surgical equipment to have a longer lifetime, be sterilised more easily? I don't know whether you want to bring Alan in on this one as well.
Well, absolutely, and I know absolutely nothing about it, do I? And I just pick up the bit of kit like that, throwaway bit of electrical kit. I presume the metal tip is coated, the plastic, but it's nothing. I don't know anything about it, so that's why I think this forum is great. I think the more people come together, because I'm not a natural university academic as a clinician, but yes, I'm sure there's great scope there. And Alan may know far more than me.
Any comment on that one, Alan?
Yeah, there's lots of research going on antiviral, antibacterial coatings, particularly hydrophobic coatings, which don't allow things to land on them, stay on them, all manner. And within the university, we've got some great people that are working on this.
Do you think that's been driven by COVID?
Yeah,
as well? Yeah,
very much so. Well, funding has anyway.
Great. So we've probably got time for one or two more questions. There's another one off Stephanie. Sorry, it's just moved. Where would you direct someone, David, interested in learning more about medical supply chains?
The references I would look up was someone called Professor Butter, Bhutta, who's done a lot. He's very passionate about procurement. Most medical gloves are made in Malaysia or in China, and there are serious ethical questions about the labour used to procure that equipment. And if you Google, if you look at gloves, I think it's been on Panorama, and surgical instruments. Traditionally, a lot of surgical instruments were made in one town, the name of which I forget, by children in Pakistan, working with in sort of the foundry conditions. So I can, if you email me, I'm happy for Lauren to share my email address. I can send you some contacts. But I'm in a minority talking about it in healthcare, I would say. I think everyone realizes it's important, but it's still not as much of a priority to people as I think it should be.
Yeah, it's great to hear, especially coming from the single-use plastic angle as well. It's fascinating. So there's no more questions, but we have just had a comment off Maggie as well, saying how interesting it is to hear that convenience has been the driver in medical practice previously. So she talks about being involved in a biology research lab where sustainability is more obvious now, and we're trying to change the culture. But wasn't sure that was the case in medicine. But as you say, it's perhaps not everywhere just yet.
Yeah, I think it's coming. I think the tide's turning. So every medical meeting now is starting to have a section on sustainability. But I think the level of understanding, say, compared to other people in the university interested professionally in sustainability, like in the Tyndall Centre, is a long way off. And most surgeons probably don't even know what anaesthetic gas has been given to their patient. So that I tell them to ask. So desflurane shouldn't really be used. But that's been an easy fruit to pick, to be honest.
Well, thank you both for that. You've got lots of thanks in the chat as well. It's been a fantastic seminar, and we're really grateful for you coming along. And if anyone wants to obviously get in contact with either Alan or David, then please do. And we'll call it to a close for today. But thanks again, and best of luck.
Thanks for giving us the opportunity, Helen and Lauren, whoever else is involved. It's been really useful and interesting.
And Google greener operations. But the survey isn't out till next week or the week after, so don't forget.
Complete the survey. We'll add that somewhere if we can to the website as well, the Sustainable Futures website.
And I'll tweet it to you.
Brilliant. Okay, thanks all. Thank you very much. Bye.